Hello. We're going to talk more about these two-player zero-sum games, and in this chapter we'll be focusing on the payoffs that player 1 is getting. Now remember that we can structure the payoffs into a matrix like you see, and this works as follows. Player number 1 picks a row, let's say row number 2, and player number 2 picks a column. This uniquely determines an entry, which is the amount that player number 2 has to pay to player number 1. So here player number 2 is paying $5 to player number 1. Now there's something called a saddle point in these matrices, and we can find them by locating a column maximum that's also a row minimum. If you stare at this matrix long enough, you'll notice that in this column the 2 is the maximum entry, and if you look at the middle row, then 2 is also the row minimum there. So this 2 here satisfies the definition of a saddle point. Now why are these saddle points interesting? Well, that's because by picking column number 2, then player 2 can guarantee that he pays at most $2. Also, if player number 1 picks row number 2, he guarantees that he's going to get at least $2. Now this implies that the value of the game is equal to 2, because player number 1 can guarantee to get at least $2 and player number 2 can guarantee to lose at most $2. These games can have more than one saddle point. That's not the case here, but in bigger matrices you have room for more saddle points, and we'll see that if that's the case, then the saddle points have the same value. Now we'll also have a need for, so here's a 3x3 matrix which we want to make smaller in order to make our life easier. Now here notice that the last column satisfies the following property. The 4 here is bigger than the 0 next to it. The 3 here is bigger than the 2 next to it. And the 2 here is bigger than the 1 next to it. This means that player number 2 will never ever want to pick column 3. Because if he picks column number 2, in every case he'll be paying less by picking that column. So we say the middle column dominates the last column, so we can remove the last column. There's something similar that you can do for the rows. Notice now that player number 1 will never ever want to pick this row, because it's always better to pick the last row, because the 4 down here is bigger than the 2 and the 1 here is bigger than the 0. So player number 1 is always better off picking the bottom row. So the bottom row dominates the top row and we eliminate the dominated row. Now what we have now is that we have made our matrix smaller. Let's call it A prime. We're only left with 1, 2, 4, 1. And this is much easier to analyze. And in fact, we'll derive a general formula for getting out of a small matrix like this, optimal strategies for both players, as well as the value of the game. which will tell us if the game is fair or not for the players. And that's pretty much what's happening in this chapter.